السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. مرحبا بكم. معكم مستر حسام حسن، منصة البث المباشر، وزارة التربية والتعليم. النهاردة في الشغل الخاص بالريفيجن. طبعا إن شاء الله إحنا قربنا على الفاينل الخاص بالفيرست ترم. طبعا إن شاء الله نهايتنا الأسبوع القادم. هنبتدي النهاردة في الريفيجن بالنسبة الخاص نعمل حاجة اسمها السمري بالنسبة للجزء اللي احنا أخدناه في شابتر 2 وأيضا شابتر 3. طبعا هو شابتر 2 والشابتر 3 مع بعض دول بيكملوا بعض، فلذلك احنا لما بنيجي نعمل لهم ريفيجن ما بن يعني ايه، ما التجزئة ما بتبقاش زي الشابتر 1. الشابتر ده هنعمل اول حاجه السمري في الاسامبشنز في الساينتست. عندي في مجموعه من الساينتست بداوا في الجزئيه دي. نبتدي بقى مع بعض كده. اول حاجه عندي summary of the assumptions of scientists. We have Thomson's calls about the atoms assumptions and Rutherford Bohr. Now we have in Thomson's calls discovery for the electron. The atom is a solid. Now is a solid, and the atom have electricity, positive electricity. This is electricity have bonded negative particles called electrons. This is sphere is homogeneous sphere. And electricity, he means the atom is neutral atom. Now Rutherford told that the atom is not solids, but the nucleus is the small electrons. Now we have a summary, not the details for each scientist. Bohr told linear spectrum interpretations of the electron rotation and observe the expression of quantum. Now we have in this session's summary for these assumptions like Pauli and Schrödinger, Heisenberg. These scientists have the modern theory of the atom observations. Now, de Broglie told the dual nature of the electrons, called electrons is not a negative particle only, but the electrons have a wave nature. Heisenberg principle of uncertainty is told that it is impossible to detect the speed of electron and its location in the same time. Schrödinger observed the wave equations of an electrons, and it told that we can to determine the accurate location of electron, but he suggests the electrons may be found in places around the nucleus in the space, but he had a major location in many spaces, and it's told equals to orbital. Now we review about the sublevels and quantum numbers. Sublevels and quantum number in the periodic table. We have many principal quantum number 1, 2, 3, and 4. K, L, M, N. Now each N have sublevels, subsidiary or secondary quantum number L. L 0 and 1, 0, 1 and 2, 0, 1, 2 and 3, 0, 1, 2, 3 and 4. Now it is the limited is 3. 0 is S sublevel, 1 is P sublevel, 2 is D for sublevel, 3 is F 4 sublevels. Now S starts from 1s, B starts from 2p, D starts from 3d, and F starts with 4f. I want to note the summations or the number of sublevel in each principal level. Principal level 1 have 1s sublevel, the number of sublevel is 1 sublevel, 1s. Now in principal level 2, we have 2 sublevels S and B, 2. Number 3 have 3 sublevels SB, 3S, 3B, and 3D. So we have 3 sublevels. In principal level 4, we have 4 sublevels, 4S, 4B, 4D, and 4F. This is number equal to 4. Now each sublevels have ML, which the meaning of what the meaning of ML? This is the magnetic quantum number. Magnetic quantum number ranged between negative L to positive L. So we have in 0 equal to 0. We have in 1 equal to from negative 1 to positive 1. 2 equal to from negative 2 to positive 2. 3 equal to from negative 3 to positive 3. Negative 3, negative 2, negative 1, 0, positive 1, positive 2, and positive 3. Now we want to do the summations of number of orbitals in each sublevel and in each principal quantum number. Now we have number of orbitals here equals to from this low to L plus 1. 1 have 1, 2 equal to 1 and 3, 3 equal to 1, 3 and 5, 4 equal 1, 3, 5 and 7. Have equal principal level 1, have 1 only. 2 have 4, 3 have 9 orbitals, 4 have 16. Now we have limited for this number of orbitals equal the relation n square. N square 1, 1, n square 4, 3 square 9, 4 square 16. This is a rule to calculate the number of orbital in each principal level. Number of orbital in each sublevel from the low to L plus 1 to L plus 1. Now we have L equal to 0, 2 plus 0 plus 1 equal to 1. Okay, 2 plus 1, 2 plus 2 plus 1 equal to 5. Now we have in these sublevels equal to 5. Now we can to calculate the number of orbitals. S equal to 1 orbital, B equal to 1, 3 orbitals, D equal to 5 orbitals, and F equals to 7 orbitals. What are the basic assumptions of which Thomson and Rutherford agrees? Now we discuss the agreements between two sciences to discuss these things. Now Rutherford and Thomson have the same idea about atoms. Thomson and Rutherford all offers different models for concepts of the structure of atom. But there are some basic hypotheses they agreed on. Number 1 is the existence of atoms. Now, they agrees about the atoms. They all agree that matter consists of small units called atoms. And atoms as essential parts. We have in the last Dalton's called, but in this curriculums we haven't Dalton's, but it makes Dalton's. Atoms essentials in this part, Dalton's considers atoms indivisibles, and Thomson called that. While Thomson and Rutherford discovered the presence of atomic particles such as electrons and protons. Now, what are the difference? Now we discuss the difference between Thomson and Rutherford. Thomson's and Rutherford's about atoms, the atom as individual particles. Consider these atoms as a solid indivisible ball. This is Thomson. Atom is indivisible particles. Consider the atoms as solid indivisible ball, lake of subatomic particles. Now, there was no perceptions of smaller particle inside the atoms. Now, Thomson models the atoms as positively charged sphere. Thomson suggests that atom is a positively charged sphere that contains negatively charged electrons distributed within it. That is the suggestion of Thomson. Now, discovery of the electrons. Thomson is the father of electrons because he discovered the electrons inside the atoms by using the vacuums. By using the vacuums, discovery of electrons, he was the first to suggest the existence of electrons as negatively charged particles inside an atom. Now, Rutherford's model, central nucleus. He discovered the nucleus. He discovered the protons, but he doesn't discover the electrons. Electrons, Thomson is the discoverer for is the discoverer of electrons. Rutherford discovered that the atom has a small positively charged nucleus, and this nucleus is positively charged because it have protons, and the protons have positive signs. So the central nucleus, so Rutherford discovered that atoms has small positively charged in the center, and the electron orbital, it has been suggested that electrons orbit the nucleus. The electron rotate around the nucleus by using the attraction force of the nucleus, the specific path similar to the solar system. Now, what are the first three quantum numbers for each of? Now we have this number 2s, 2s, 4d, 5f, 6b. This is the questions. What are the first three quantum numbers for each of 2s, 4d, 5f, and 6b? Now, focus on this area, please. Now, n equals to, here is 6 for p. Here is 5 and f. Here is 4 and is d. And here is 2 in S. Now, next in L. L equals to, P equal to 1. Okay, this is 1. F equals to 3, right? D equals to 2, that is right. And S equal to 0. This is the secondary quantum number or subsecondary quantum number. Now we have ML. ML here is 0 what? From -1 to +1. And F is from -3 to +3. Now here is -2 to +2, we have 0. Now, in this slide, distributed the following atomic number. Okay, you must write the atomic number here: 42, 37, and 17. And we have another 25. Okay, first things we discussed: 25. 25 we need these things because argon equal to 18. This is the closest inert gas or the closest noble gas used to summarize to decrease the mistakes or for this distributions. Now we have 18, 3d5, 4s2. You can write argon 18, 3d5, 4s2. 18 plus 2, 20, 20 plus 5 equal 24, 25. This is the true electronic configuration. Next, 17. 17 is Ne10, 3s2, 3b5. 10 plus 2, 12, plus 5 is 17. Now, 37. 37, it is the closest noble gas is 36, is krypton. Now, krypton 36, 5s1. And another 42. 42 is krypton 36, yes, 5s1 is anomalous distributions because we want to reach the established things, stability. 45 is more stable, 44. Okay. And we need to know the classifications of elements. We have many classifications of elements. It's classified if according to sublevel S, B, D, and F. We have firstly by sublevel. Sublevel, we have representative elements. Representative elements, we have C block and P block. S block NS from 1 to number 2. B block from P1 to 5. Okay, this is representative elements, and this representative element distributed in two sides, S in the left side of periodic table, B in the right side of periodic table. Now we have main transition elements, ND, NS from 1 to 2, N minus 1D from 1 to 10. We have inner transition elements, F for F and 5F, NS from 1 to 2, N minus 1D 1, and N minus 2F 1 to 14. We have the last is noble gases. Noble gases 1 is 2 or NP6. 1 is 2 only in the first noble gases, in the last group in the periodic table, in the right side of periodic table. Now we have this classification. Now we can't know the classify of any element or any atoms by electronic configuration and search the last sublevel you distributed and for the electronic configuration. Now you can detect the classification of the element. This is a section. Now this is the all periodic tables. We have this classifications. We have 4F and 5F. Now this is a periodic table. We have many sides. In the last size is S. Left side is S from 1S1 to 7S1. This is a group 1A. And the left we have P from B1 to B5. This is as a representative elements. This is a noble gas. This is the main transition elements in the middle of periodic table. Now here is 4F and 5F in the below of periodic table. Now this is the inner transition elements. We have the representative elements. I illustrate you for this. Now we have an example. This example explain the type of each element here. We have in this 20, calcium is 20, okay, 20, the last sublevel is 4s2, 4s2, so is representative elements, S block. We want to know the quantum numbers of this atom. N equal to 4, L equal to 0, ML equal to 0, MS equal to negative half. Now, sodium 11. Sodium 11 is 3s1 is the last sublevel you distributed. N equal 3, N equal 3, L equal to 0, ML equal to 0, MS equal to positive half, because we have one electron only in S. This is representative element S block. Chromium 24. Chromium 24 is distributed 3d5 for S1. Now we have the last one is 4 or 3? No, it's 3, because you start with 4s and next is 3d. So the last sublevel you distributed in number 24 is 3d5. So we have n equal to 3, L equal to 2, ML equal to positive 2, and MS equal to positive half. Okay, another strontium 38. Strontium 38, 5s2, representative elements. This is a main transition element, but here is transition, not transition, this is representative element, S block. 5, N equal to 5, L equal to 0, ML equal to 0, MS equal to negative half. Main transition elements, this is iron 26. Iron 26 when distributed is 4s2 3d6, 4s2 3d6. Last, you have last distributed in 3d6, you have last distributed in the 3d6. Now we have n equal to 3, L equal to 2, ML equal to negative 2, and MS equal to negative half. K19, if you make distributions of this number equal to 4s1, n equal 4, L equal to 0, ML equals to 0, MS equal to positive half. Now, to refer another, we have in this slide x16, y26, z58, r37, b equal to 18. This is the atomic numbers of these elements. We have different atoms. What is the type of each element, and what are the 4 quantum numbers for the highest energy electron in each atom? Which the highest electron or highest energy electron? It is the last electron distributed in the last sublevel, in the last main levels. Now we have the electronic configuration for each one. This is the atom is x16, x16 equal to 3b4, and the type is p block. Last sublevel equal to, this is here, this distribution of electrons here and the orbitals. So n equal to 3 and L equal to 1, ML equal to negative 1, and MS equal to negative half. Next we have Y26. Y26, its electronic configuration ended with 3d6, so is d block because it's transition or main transition element. Electronic configuration in its orbitals equal to, we have, and like that you see. Now n equals to 3, L equals to 2, and ML equal to negative 2, MS equal to negative half. Z34, Z equal to 58. Now you was you this is ended with 4F1, so it is the inner transition element. In a transition element, electron distributes in one orbital only. So N equal to 4, L equal to 3, ML equal to negative 3, and MS equal to positive half. We have R37 5S1. We have, it is S block main transition elements, and we have 1 only and 5S1. So it's the N equal to 5, L equal to 0, and ML equal to 0, MS equal to positive half. And we have a B18 is 3B6. 3B6 is noble gas. The electron configuration in these orbitals, they are paired electrons. So N equal to 3, L equal to 1, and ML equal to positive 1, MS equal to negative half. We ended this distribution now. Now, elements class S and B. We have electronic distribution of the last sublevels. Now, S1, S2, S2B1, S2B2, S2B3, S2B4, S2B5, and S2B6. Now, we can know, and you can detect the group number by using this. If S equal to 1, so the group number is 1A or 1. 1A or 1. 2, 2A or 2. 2 plus 1, 3A or 13 or 30. Okay? S2, B2. 2 plus 2, 4. 4A or 14. S2, B3. 3 plus 3. 2 plus 3 equal to 5A or 15. 15, this is the number of columns here. S2, B4. S2, B4. Now it is 6A or 16. S2, B5, 7A or 17. S2, B6, and 0 group or 18 columns. This is each elements or each atoms is representative elements. The body numbers is defined from the number that precedes the farthest sublevel S or B. The number before S, last S, or last B, you can to know the number of period here. Main transition elements you can detect the number of groups. Again here, electronic distributions of sublevels NS2, N-1, D1, D2, D3, D5, and S1, D5, D5 in S2, D5, D6, D7, D8, and S1, D10, and S2, D10. So we have these numbers. You can do summation 2 plus 1, 3B or 3 on column 3. Okay, 2 plus 2, 4B or 4 column. 2 plus 3, 5B, 5 columns. 1 plus F, 6B or 6 column. 2 plus 5, 7B or 7 column. 2 plus 6 is 8. From here, you have anomalous. 2 plus 6, 2 plus 7, 2 plus 8, they are in A group because they are very similar atoms. So it is number from 3 columns here equal to 8, 8, 8. But it is the column 8, 9, 10. Now in S1, D10, 11. This column 11, but is 1B, 2B, or 12. This number distributed, that we have these atoms. How can you locate the following atoms on the periodic table? I have 32, 16, 35, 32, 37. Okay, you must make configuration of each atomic number for these atomics, for these atoms, to know the location of each atoms in the periodic tables. Firstly, we have 42. 42, K, 36, 4, 5S1, 4d5. Okay, we want to know the location of these atoms here in period 4 or 5, period 5. We period 5 because we called before the number precede the last sublevels. But last sublevel here, I'm sorry, last S or P, last S or P. Okay, this is the period 5 and 6B or 6B or 6, period 5 and group 6 or 6B. Now transfer another atoms. 37. Electronic configuration is krypton 36 5s1. So the number of group is 1a or 1. Period is 5. So the period equal to 5 and number of group is 1 or 1a. 16. 16 neon 10 3s2 3b4 3b4. So the period is 3 and group 6a or 16. Now this period is 3 and group is 16 or group 6b, sorry 6a. 32 now is argon 18 4s2 3d10 4b2. Okay, now period 4 because the last S or last B equal to 4 precede this sublevels, but D is 10. So we can do summation of these 2 plus 10 plus 2, so equal to 14 or 4A. They are true. Okay, this is the training or exercises for each year of each things about the electronic configuration and the location of each atoms in the periodic table, and you can detect the number of groups of any atoms you want and number of quantum numbers for quantum number for each. You can't detect any things here for these things. Now we are finished any things here and this revision, and thank you for good listening, my dear peoples in our Egypt, and thank you and assalamu alaikum wa rahmatullahi wa barakatuh.